Problem number 1 asks for us to complete the property proof. Now this is basically similar to solving a proof as we talked about in class, but you're looking at each step on the left and seeing what change took place between step 1 and step 2. Now we also talked about in class when you get to high school you'll do proof statements similar to these, and step 1 is typically a given. That will make more sense when you get to high school and you see the application of this in a geometric sense. But right now, I just want you to get used to step 1 typically being given. So, step 2, we want to know what change took place from step 1 to step 2. And we should realize the only thing that took place that's different is this 1 got distributed to both terms inside the parentheses. And so we do have a property for that. We call that distributive property. So now, to answer 3, we want to see what change took place from step 2 to step 3. And here we notice that there was an 8 outside the parentheses. It came inside the parentheses. The x got removed from the parentheses. And so we talked about in class how the 8 inside the parentheses no longer wanted to associate with the x, so it kicked it out of the party and brought the 8 that was out of the party inside of the party so it could associate with it. And so we call this the associative property. And here the operation is addition. So our associative property of addition. All right, question 4. What change took place from step 3 to step 4? All right, here we should notice the only thing that really took place as far as a change is this term, 8 minus 8, switched places with x. The 10x came to the front. And so we basically reordered the problem. And we can certainly reorder the problem. We have a property that goes along with that, and we call that the commutative property of addition. And so our illustration in class was that when you travel from home to school, that's no different than traveling from school to home. The distance is the same, and you often take the exact same route. So we compare that commute with the commutative property, where the order of these really does not impact the outcome or the result of the problem. So next we want to see what change took place. We notice 8 minus 8 becomes 0. And we talked about in class how we could rewrite that with addition. So that would be 8 plus negative 8, where we would then realize we're adding its opposite. And that's our definition of additive inverse. A number plus its opposite equals 0. And last but not least, we want to identify the change from step 5 to step 6. 11x plus 0 is equal to 11x. Anything plus 0 is equal to itself. That's our identity property of addition. Number 2. Again, we're going through the same steps. So step 1 will always be given. Step 2, we should see that from step 1 there was some distribution that took place. So that's the change from step 1 to step 2 was distribution. So distributive property. No, we don't need to say F. That's only for addition. All right. And then from step 2 to step 3, well, we can see some things got rearranged in order. So that's going to be our commutative property. And then lastly, I went ahead and gave you the answer because all that took place was the 5x plus 2x combined in like terms, and that became 7x minus 50. Question number 3. Identify the GCF, or the greatest common factor. And we use greatest common factors to factor problems down into their simplest form. And so if I'm looking for a greatest common factor, I want to know what in this term has an identical factor in the second term. Or we could ask, what could I divide both of these numbers evenly by? Well, obviously the factors of 5 are 5 and 1 because it's a prime number. So we need to ask ourselves, is 60 divisible by 5? And it is. So our GCF would be 5. Next problem. Anytime you see repeating numbers that are double digit, we should get a good strong indication that they're divisible by 11. So I can tell right away that both of these terms are divisible by 11. But not only are they divisible by 11 as a common factor, but both terms have the exact same variable, which would serve as a common factor. So we could divide both terms by 11r. Number 5, 16xy, 40x. Now, since we know our factors of 16 are 1 and 16, 2 and 8, 4 and 4, we want to figure out which of those are going to be our greatest factor for 40. So let's list them so we can see them. 1, 2, 4, 8, and 16. Do any of those factors go evenly into 40? Well, 8 goes evenly into 45 times, 4 goes evenly into 40, 2 goes evenly into 40, but 8 is going to be my largest factor, or our GCF. Now, just as we did in the previous problem, we want to look and see, are there any variables that are identical in both problems? Because if they are, they can also be factored out. In here, we should notice we have x in both problems, so our GCF would be 8x. Number 6, 36xy plus 45y. So again, we're looking for our GCF. And so we could certainly list out our factors if we want. We have 1 and 36. We have 2 and 18. We have 3 and what would be 12. Looks like we have 4 and 9, so I'm going to come down here and make more room. We have 6 and 6. Now, once I've repeated a number, it's generally a good indication that we are at the max of our factors, because 7 would not go in, 8 would not go in, 9 would go in. Now we're back to our 9 and 4, and we're going to work back in the other direction. So now we want to ask, which of these numbers is going to go into 45 evenly? Not 1, not 2, 3 would, but is it the greatest? 12 would not, 18 would not, 36 would not, 4 would not, 9 would go into 45. So our GCF is going to be 9. And when we divide 36 by 9, we want to know what's left. So that's going to leave me with 4 left. And notice I'm leaving some space because we haven't dealt with the variables yet, so we're going to come back to that. When I divide 45 by 9, that gives me 5. And so now let's talk about the variables. Are there any variables in both terms that are the same? Well, yes, there are. Y is in both terms, which means we can factor out the variable y, because if we divide both terms by y, it would disappear. And so I'm going to bring my y over here next to the 9 because that's part of my GCF. That's our factor. And now we want to see what's remaining. We said the y's would cancel out when we divided by y, so that leaves with x. And we said the y would cancel out when we divide by y, so that's going to leave me with no variable on that side. Now there's a quick and easy way to check your solution. The quick and easy way to check your solution is take your outside term and distribute. So 9y times 4x. Well, 9 times 4 is 36, xy. 9y times 5. Well, 9 times 5 is 45, y. Number 17. It is certainly possible to factor out a 3 from all of these terms. So I would take that as one option. I would also accept you combining like terms and then simplifying. So let's see what each looks like. If I were to factor out a 3, 3 would go into 15 5 times and leave me with 5a, plus 3 would go into 3 one time, which would leave me with a, minus 3 would go into 18 6 times, which would leave me 6b. Now we, from here, should realize, hey, I can combine like terms, and that's going to give me 3 times 5a plus 1a is 6a minus 6b. And right away we should realize, hey, I have got a common term, 6. So we could factor yet again to get the 6 out. 3 times 6, that leaves me with a minus b in parentheses. Well, 3 times 6, 18, a minus b. Now I told you there were two options for solving this. One was to factor and then simplify, which we noticed then we had to factor again and simplify. Option 2 was to go ahead and combine your like terms. So 15 and 3a would give us 18a minus 18b, where now we should realize pretty quickly that the factor would be 18. 18 times a minus b. Number 8. 11xy plus 12y plus 13yz. And here we don't have any terms that have a common numeric factor. In other words, 11 and 12 and 13 have no factors in common other than 1. So the numbers themselves are not going to simplify out. But we should recognize that each term has a y in it, so we could factor out the y. Then we start asking ourselves, what is 11xy divided by y? And that will simply cancel out the y's and leave us with 11x. Next, 12y divided by y. That's going to leave us with 12. Next, 13yz divided by y. That's going to leave us with 13z. Now we're done with our first 8 problems.